Hey guys, welcome back to the Makefile series. The next few videos are going to be different from the previous ones. In the previous ones, we wrote a functioning Makefile to serve a purpose. So for example, to build a C project or just to give an introduction to Makefiles. For the next few videos, you can actually see a sneak peek on the left. We are going to go over the features and functionality of Make. So in the next section of this tutorial, when we start writing more sophisticated Makefiles, we're going to have these videos and these individual Makefiles to fall back on and to refer to recall how specific features of Makefiles work. So with that said, let's get started. And we're going to start off with some more rule syntax. Now, we saw previously that this here is the general syntax for a rule. You can have multiple targets, and then you have a colon, which separates the targets from the prerequisites. The prerequisites are other targets that these targets depend on. And finally, on the next line, you have your recipes. So you can have multiple targets, you can have multiple prerequisites, and you can have multiple recipes. Now we can see that you actually can put the recipe on the same line as the target as long as you separate it with a semicolon. The main use case is in functions, which we'll get to later, but also it's useful if you ever want to create a blank recipe. So if you have a tab that has, a blank recipe, there's nothing here, you don't actually see that there's a tab there. So if you ever want something to be a blank recipe and you want people to know that it's blank, you can just put a semicolon. Now, moving on, we have double colon rules. So the difference between this and normal rules are that double colon rules extend one another. So let's try to run this makefile. And as you noticed, the makefile is not named makefile. It has another name. And we can specify what that is with the -f switch. So we say it's in the 3 make essentials directory and the name is one more rules. That's going to run this makefile. So to run this double colon rule, let's say double colon rule. And I brought it back down to 1 colon. Let's run it and see what happens. We get these two warnings saying overriding recipe and ignoring old recipe for this target. So if you ever have two rules with the same targets, the recipe from the second rule is going to overwrite the first rule, except if it's a double colon rule, in which case it's going to print out both, or it's going to run both of those recipes. This is useful especially if you have different prerequisites for different stages. So this can have one dependency and this can have another dependency. And whichever dependency triggered this rule, only that part of the rule is going to run, which I think is kind of cool. Realistically, I haven't had a use case for this just yet, so keep that in mind, but I think it is pretty neat. Moving on, we have ordered rules or order only prerequisites. These are different from normal prerequisites. Now, normally a target is built if it doesn't exist or if it exists but it is out of date, meaning it is older than its prerequisites. If you put a pipe and then you put your prerequisite, you are saying that this prerequisite is not relevant to the modified time of the target. It doesn't matter which one is newer or which one is older. All that matters is that this prerequisite exists. So go in and play around with it. This is useful if you have a target that builds a directory, for example, and you don't care if that directory has been updated more recently or older or whatever. All you care about is whether that directory exists or not. So again, play around with it, get to know it, or maybe ignore it until you have a use case for it. But it is there. It is a feature that exists. So moving on, I'm gonna clear this part out. We have 3 prefixes. So these are things that we can add to our Makefiles. And what they do is, for the @ it removes the recipe from being printed. So let's run this command. And the thing is hide, oops. the recipe, the rule is hide recipe, and we only see the result of this. We don't actually see the command itself being printed out. Normally, without the at, you see the command itself. So that's kind of useful if you want to clear up your prints. The next prefix is a minus sign, and this ignores errors. So if we actually have another recipe here that doesn't ignore it, let's try that out. And we can see that both of them failed because the command false is a command that fails. The first one was ignored, but the second one was not ignored. So this is an actual error. And that's useful if you ever have, oops, I scrolled up by accident. That's useful if you ever have a scenario where it's okay for a command to fail. I don't know of a use case for that, but if you ever come across a situation, this is the tool to do that. Finally, we have the plus sign. And what this does is it tells make to run that command even if you run make with the dry run mode. So dry run mode is a mode that you run your make files in, like, make dash dash dry run. And what that does is instead of running the commands, it prints out the commands that it will run. And this is useful if you want to debug or develop your make file. It's not something that you do if you're actually using make to build a project, or if you're using make as an end user. So that's what the plus does. Hopefully you don't need it, but if you do, it's there. Moving on, we have pattern rules. These are rules that have a wildcard in them. So you might be familiar with an asterisk or star as a wildcard. In make, we use the percent sign. So if you have a rule that has a percent sign, this dynamically matches a target that you specify on the command line. So you can put the wildcard anywhere you want, at the end, in the middle, or at the beginning. So to use it, we can do, for example, for the first one, we can do hello dash, anything, and it's going to match this rule over here. You can also do it with, if you add a world at the end, it's going to match this rule over here. And if you have a dash world at the end, I wonder what's going to happen. Oh, we still match the middle one. But if we remove the hello from the beginning, we will match this rule here at the end. So this is pretty useful if you have a bunch of targets that have a specific pattern. So for example, here, instead of dash world, if you have something like .o, then this is going to match any rule that ends with a .o. So it's going to match any object file. If you ever want to override a specific instance of these wildcard targets, so for example, if you want to override hello-world to have a specific recipe instead of the automatic recipes, you can just type in your exact rule that you want to override and give it the recipe, and that's the one that's going to work. So direct match rules are always going to take precedence. They're always going to have the highest priority when make is trying to match the rule to a target that you specified. If this didn't exist, which of these targets would run if I passed in hello-world? It matches them all, so any of them could run, but what's going to happen is that make is going to choose the rule that have the most characters that match your rule. So hello%world has the most characters that match, so that's the one that's going to run. Also, I just realized this one has a capital and these are lowercase, so I'll fix that before I push it up. Moving on, let me clear this out. We have prerequisite handling. So this is very important when you have multiple makefiles or automatically generated makefiles, or even just prerequisites figured out in different places. What this is when you split your rule into multiple parts. So we saw previously with double colon rules that double colon rules extend one another. But if you have single colon, so like normal rules, if you have multiple recipes, the rule that comes later on is going to have its recipe override the recipe from the earlier rules. But that's only for recipes. It's not for dependencies. What's going to happen is that the rest of the dependencies get appended to the later rules. So let's give this a shot. And if I build multiple prereqs, we see that first we build dependency 1 over here. This is first. And the recipe actually comes from down here. And we're making use of the wildcard targets already. So that's pretty useful. And after dependency 1, we build dependency 2, which came from up here. And then only after that do we finally build this recipe. So very useful feature. And if you're ever confused about why something is being run, perhaps there's a dependency somewhere that's being picked up that you haven't found yet. So keep that in mind. Moving on, let's clear that out and move on to static pattern rules. Now, these are rules where the prerequisites are they are determined dynamically based off of a wildcard or based off of a pattern, which is why they're called static pattern rules. What happens is that if you have multiple targets that have some pattern to them, you can explicitly specify that pattern. So we see %-trip, and that's the pattern we have, Asia trip, Europe trip. We say that the prerequisites are static dependency wildcard, or here actually the correct term is stem. So here we could call it a wildcard, and here we can call it a stem. So Asia trip is going to have a static dependency on static dependency Asia. Europe trip is going to depend on static dependency Europe. Note that Asia trip is not going to depend on static dependency Europe, and Europe trip is not going to have a dependency on static dependency Asia. So let's run that and give that a quick shot. So Asia trip is going to say packing bags for Asia and then trip to Asia. And for Europe, it's going to be the same. We're going to be excited to visit Europe, and then we're going to do the trip to Europe. We can also do them back to back, and the dependencies are as you expect. They only stay according to the prerequisites only stay attached to their own targets. So moving on, finally, we have PHONY targets. These are targets that aren't files. As we saw previously, recall from the first Makefile video, you expect that a target matches a file. And so if that file doesn't exist, when you run the rule is expected to create that file. PHONY is the opposite of that. It says that this target is a target that does something, or it depends on prerequisites that do something, but it itself is not a file. So if I run this over here, not a file, it's going to run that command. And if I do it again and again, it's still going to run it. If I actually create the file and then I run this, it's still going to run this command because it doesn't care whether that file exists or not. It says I need to run this command. Now, this is useful if you're creating some type of functionality that isn't actually a file. It's an abstract concept. So typically you have 3 examples, all, clean, and test. So all could depend on the actual target that you want to build. Clean could be a target that actually removes some files. So you might do rmrf, build directory or rmrf star.o. Clean is not an actual file, it's a concept. So in cases like that, you would use your PHONY targets. The advantage is twofold. Number one, if someone accidentally creates a file called clean, or perhaps you have a directory called test, this rule is still going to run even if that exists. So there's an advantage from the functionality perspective. And from a performance perspective, since make doesn't check to see if the file exists or not, it's slightly faster. So that's all for this video. In the future videos, you can kind of see over here, these are subject to change, but that's the general idea. We will go over more features, more functionalities. So stick around, and I hope to see you next time.